Hello, students of science. Let's talk about distance, velocity, and time. We're going to talk about how you measure and calculate distance, velocity, and time. Now, first off, we need to go over some vocabulary, the difference between speed and velocity. Speed describes how far something moves in a certain amount of time. Here we have Usain Bolt running, breaking, I believe this was the world record for the 100-meter dash. Now, we don't say he's fast because he ran 100 meters. I can run 100 meters. I just can't do it very quickly. So we say it's not the distance you want, it's how far you went in a certain amount of time. The SI unit, the metric unit that we're going to use for this is meters per second, or m/s. Velocity is a little bit different. Velocity is speed with a direction. So that's what we're going to be looking at. Speed is just how far you go in a certain amount of time. Velocity is speed and a direction. Here we have Bolt crossing the finish line. Okay, I'm sorry. All right, so let's take a look at some examples. I want you to write one of each. Example of speed is 70 meters per second, so distance over time. Velocity, however, would be something like 24 meters per second north. There, I've added in a direction. Another speed example, 94 kilometers per hour, That is a speed. That's distance divided by time. Velocity would be 120 kilometers per hour straight up, like, a rocket ship or something going up. There I have a direction. That's a direction. 60 miles per hour, that would be an example of a speed. That's right around the top speed of a cheetah when it's in full sprint. But again, that's bad. Please don't use the imperial system. Please use metric. A velocity would be like 0.2 meters per second southwest, which is something like the speed of a snail. Get it? Because the snail's on a turn. It's like, slow down. Okay. Now, I want you to copy. You don't need to write anything on the slide except for this triangle here. So this is what we call an equation pyramid. These make solving a lot easier. Up top, I have D. That D is for distance. So my units are meters. Beneath it, I have T for time. My units for time are seconds. And V for velocity is meters per second. So copy down this pyramid onto your paper. You're going to need to know this. Is going to be really handy. We'll go over how to use that in just a second. Okay, a gazelle ran 130 meters in 15 seconds. What was the velocity? So we're going to fill this out by putting in our different parts here. My distance was 130 meters. My velocity was unknown, so I'm going to put a question mark there. And my time was 15 seconds. Now, what I'm left with is velocity is distance divided by time. So the next thing I'm going to write is V equals D over T. So that's my velocity is distance over time. Now I'm going to plug in my distance of 130 and my time of 15 seconds. That is going to give me 8.67. And I need a unit, and our units for velocity is meters per second. Okay, let's talk about the difference between average and instantaneous speed. Average speed is what you calculate for an entire trip. Like, hey, I went from here to Madison, Wisconsin, or here to Denver, Colorado. That is the total distance divided by the total time. Example, you don't need to write this down, but I do want you to write this part. Remember, anything in parentheses you don't need to write. A family took a road trip to Madison. It took 4 hours to travel the 400 kilometers. What was their average speed? So I take my total distance, which was 400 kilometers, and the total time, which was 4 hours, and I calculate that to be 400 divided by 4, 100 kilometers per hour. Now, they may have been going faster than 100 kilometers per hour, which is about 62 miles an hour. They may have been going slower, but this is my average speed over the entire thing. You have to factor in stops or areas where it's slower, areas where they went fast. It's an average. Now, let's compare that to instantaneous speed. Instantaneous speed is the rate that an object is moving right now. And you have to measure that with one of two instruments, either a radar gun, which is something the police officer might use for you, or a speedometer. Obviously, the police officer is probably not sitting in your car saying, you know how I know you were going 80 miles an hour? You're like, yeah, you were sitting in the passenger seat. Police officer is going to use another thing here. And the police officer doesn't care about your average speed. You can be like, oh, but I was averaging 62 miles an hour. And they'll be like, I don't care. You were doing 90 in a school zone. They care about your instantaneous speed, how fast you're going right now. Now, in a distance versus time graph, the slope of the line is the speed. So if I have distance on the y-axis and time on the x, this means that the slope The angle of that is the speed. So here you can see on these lines, Pierre, those little red bug, is climbing uphill. This one would be a higher speed because it's a higher slope, lower speed because it's a lower slope. A constant speed is one that is going to have a straight line, whereas a changing speed is going to be curving up or down. But constant, same slope. Changing, different slope. So in a constant speed, the slope never changes because it's constant, whereas you change the speed, you're going to change the slope. Constant speed is characterized by straight lines. A changing speed is characterized by either curving up or curving down, speeding up or slowing down. And if we have a line that is horizontal, that's straight, that is an object that is not moving because its slope is 0.